we would like to discuss about the characteristic of fluid. A fluid is defined as a substance that deforms continuously when acts on a shearing stress at any magnitude, as written here. In a fluid at rest, normal stress is called pressure. So later on, the first chapter in Fluid Mechanics 1 is EMM 2313. So we will discuss about the pressure. However, in this slide, I would like to discuss about the common parameter and most important things that you need to know before we could learn more about fluid mechanics. So and then I hope you could understand about the units and dimensional. So we have in fluid, we have qualitative and quantitative characteristic. The qualitative characteristic is to identify the nature of fluid, such as a length, time, stress, and the velocity. Basically, the qualitative aspect identifies the nature or type of characteristic. So the another one is the quantitative parameter. So it is a numerical measure of the characteristic. Quantitative require both a number and a standard, such as standard are called units. Okay, for example, number 3 is quantity and kilogram is unit. So for example, we have a 3 kilogram here. So 3 is the quantity and kilogram is a unit. So the common quantity in mechanical engineering is length, time, and mass. And temperature will become a very unique quantity because the symbol theta is actually unique. So and then we could have secondary quantity, means that the multiplication of the primary quantity. For example, if we want to calculate the area, so we could multiply the width and the depth, for example, so the unit will become meter square. And then in this system, so to neglect the various unit, so we just assume that the length can be shown as L, the time is shown in T, and the mass is shown in M. So for example, if we calculate the area, so it will become meter square, so it can be written as L square. And then the velocity is L over T, so we could write as L T to the power of -1, and the density is kilogram per meter cube, so we could write as ml to the power of -3. So and then all theoretically derived equations are dimensionally homogeneous. So the dimension of the left side of the equation must be the same as those on the right side, and all additive separate terms must have the same dimension. So this is very common. If you have an equation, please make sure that the unit in the left hand side must be equal to the unit in the right hand side. So this is the common physical quantities. So we have a lot of parameters here. We have acceleration, for example, density, mass, length, and so on. So however, in this world, so we have two major systems. One is called an MLT system. So it is based on mass, length, and time. So however, another part of the world, they still use the idea of FLT system. So there are no right or wrong here. So it's depend on the best condition for each country. So for FLT system here, so the L and T will refer to the same thing, which is length and time, but F here will refer to the force. So means that all calculation is mass is based on the existence of force on that system. However, in MLT system, we will be focused on the existence of the mass in the system. So and then in units, so commonly we have two major units in this world. So one is the British unit, which is the foot, the second pound and Fahrenheit, and then the other one is the SI unit, which means the length is measured in meter, time in second, mass in kilogram, and temperature in Kelvin. So and then I hope you still remember the conversion between degree Celsius and Kelvin, which is which can be written like this one. So and then in this subject, please make sure that you understand the prefix. So for example, the common one is millimeter or centimeter here. So if you have a word milli here, so it is equal to 0.001 or 10 to the power of minus 3. So and then for the bigger amount, we could have mega, giga, and tera. And then for the smaller one, so maybe we have a micro here. So and then we have a pico, nano, and pico, and then it goes to femto and atto. So this is good for you to remember the meaning of the prefix in the units. So now I would like to share with you 4 important parameters that you need to really understand before we could get analyzed or we could go further in fluid mechanics. Number 1 is density. So density is designated by the Greek symbol of rho. So you could write the rho here like this. So you just have something like P, but it's inclined to your left like this one. So this is the rho, and then it is defined as mass per unit volume. So it is the unit is kilogram per meter cube. Then we could have specific volume, which it is the volume per unit mass, and this property is not commonly used in fluid mechanics, but it is used widely in thermodynamics. If it means that here the specific volume can be written as 1 over rho like this one. However, this is widely used in thermodynamics. This is the graph of the density of water. So we found that if the temperature increase, so the value of density here will decrease. And then normally we could take density of water as 1000 kilogram per meter cube. So however, for the specific one, so the density of water equal to 1000 kilogram per meter cube only at 4 degrees Celsius. But normally in your calculation, it is okay for you to use the density of water as 1000 kilogram per meter cube for any temperature of water. So normally in this subject, fluid mechanics 1, so the temperature is around is at the room temperature, so it is around 30 degrees Celsius. So the density of water is around 994 or 996 kilogram per meter cube. But as I said, it is okay for us to use the density of water as 1000 kilogram per meter cube. So this is the table showing a few density of a few common fluid. So what I need you to understand here, please remember a few common fluid here. So the first one is water. So you know the density of water is around 1000 kilogram per meter cube, or around, or here in this table it's give as 999. So and then if you have another one is mercury. So for mercury, please remember that the density of the mercury is 13,600 kilogram per meter cube, which is 13.6 more compared to water. So and then if you could see here, so for seawater, so it is water mixed with salt, so the density is a little bit higher compared to the plain water. So the density is around 1030 kilogram per meter cube. So and then if you have oil, for example gasoline here, the density of gasoline is lesser compared to water. That's why if we mix oil, gasoline and water, gasoline will will floating on the top of water, because the density of gasoline is lesser compared to water. So I hope you could remember all these density, because sometimes we we are not giving you any amount of density for common liquid. So the second parameter is called specific weight. So it is designated by the Greek symbol gamma, and is defined as weight per unit volume. So if we have weight here, so we divide into its own volume, so it will become mg divided by volume. So and then it will become, the unit is kilogram times acceleration of gravity and meter cube, and then it can be simplified as rho times d. So please bear in mind or remember this gamma, which is the specific weight, is equal to rho and g. So and then if you want to write the unit of this specific weight, you could have rho is kilogram per meter cube, and then g is acceleration meter per second square. So you have here is, you could simplify the cancel the meter, so you will have the unit is kilogram per meter square and second square. So and then the third parameter is called specific gravity. It designated as SG. So in exam for this course, okay, we will use the abbreviation of SG as specific gravity. So it is defined as the ratio of the density of the fluid to the density of water at some specified temperature. So usually the specified temperature is taken at 4 degrees Celsius. So means that the density of water is 1000 kilogram per meter cube. Okay, so and then the equation will become like this. So you have the rho of anything you want to measure. So it can be solid, it can be liquid, and it can be gas. So you divide by 1000 means the density of water. So the idea of specific gravity actually is to know the ratio between the density of specific fluid. Okay, in this subject we focus on liquid and gas. So and then compare with water. So and then because we divide the value of density over density here, so means the unit of density, which is kilogram per meter cube at the top and kilogram over meter cube at the bottom. So means that we could cancel all the units here. So means that the specific gravity is dimensionless. So mean there are no unit for specific gravity. It just a number telling the ratio between specific density, showing you the ratio compare with the water. So and then if we discuss about fluid, so for sure we have two types of fluid. One is gas and one is liquid. So for gas, so I hope you could understand the idea of ideal gas law. Gases are highly compressible in comparison to liquid, with changes in gas density directly related to changes the pressure and temperature through the equation of P equal rho RT, which is P is the pressure, Rho is the density, and R is the gas constant, and T is temperature. So this is a very common equation, and I hope students start to understand that for gas it is very sensitive to temperature. So when you heat it up, so gas will expand. So then when it expands, so mean it actually we need to analyze that situation using the idea of compressible flow, because the density of the gas on that time when it expand change. So the pressure in the ideal gas law must be expressed as an absolute pressure, ABS, which means that it is measured relative to absolute zero pressure. So the absolute zero pressure is a pressure that would only occur in a perfect vacuum. So the idea of this one is actually if we do calculation on Earth's surface, so because we are surrounded by atmospheric pressure, so it is mean that actually our pressure is equivalent to atmospheric pressure. However, if we go to the space, so we found that there are no atmospheric pressure. So on that time, it is actually the condition in the space is called absolute zero pressure or a perfect vacuum. So we will discuss about the absolute pressure and gauge pressure later on in pressure chapter. For your information, standard sea level atmospheric pressure is 14.696 pounds square inch, or equivalent to 101.325 kilopascal. Okay, so means that we could take the atmospheric pressure is equal to 101.325 kilopascal. But please bear in mind that here the unit has prefix kilo. So mean every time you want to substitute this value into your equation, please write as 101,325 pascal. Because the kilopascal, the kilo is the prefix of the unit, so you need to expand the meaning of kilos. And then this is the most important parameter in fluid, because the density, the specific weight, the specific gravity, all of that parameter is actually a common parameter for all element. Means the solid, liquid and gas has density, specific gravity and specific weight. However, for viscosity, so viscosity is a very unique parameter, because viscosity only occur in fluid. So what is viscosity? So the property of viscosity is describe the fluidity of the fluid. Means that if the viscosity is less, means that the fluidity means the fluid can flow easily. If the viscosity is higher, mean it has a lot of resistance to flow. So means the fluidity is become worse. Okay. To resist, okay, let's say we have a situation like this one. Okay, so we have the situation like this one. So we have a fixed plate at the bottom, and we have a moving plate at the top. So this moving plate, so it means that we need to act certain type of force here to move this plate from left to the right. So if between these two plates, so we put a liquid, for example, so with a few type of viscosity, so you will find that if the viscosity higher, you need more force to pull the top plate. Why? Because for high viscosity, the molecule will stick very hard on this surface, and then they will resist the motion. So and then we could have the equation, or in equilibrium we could say that total forces that act on the plate here is equal to the total resistance that occur due to the existence of the fluid. So means the total resistance can be calculated as total shear stress that acts on this surface multiplied with the area. So the tau means the value of shear stress for one molecule here. So we multiply with the area of the plate to calculate the total shear stress or the total resistance that occur on this plate. So and then we could only move this plate when this force is equivalent to this resistance. So it means that the first equation that you need to understand in this chapter is P is equal to tau A. So here, because we don't want to confuse student about the symbol, so we will normally we could write force is equal to tau times A, which is the F here is the force. So the tau here is the shear stress, and the A here is the area. So it is revealed that as the shear string tau is increased by increasing force.